F science video, yay. Anyway, so yeah, we're going to talk about light some more, and photons and whatnot. So I stumbled across this video by a Dr. Mark Kubrick, part of Berkeley's award-winning online chemistry project. Yeah, it won awards. Anyway, just horrible. But this is an example of the two-slit experiment being explained by a doctor of something. And, yeah, this is just part of this, I'm going to say systemic. I've just been saying that a lot lately. I think it's a weird word, but whatever. This fundamental problem in physics. It's just bullshit. So much of it is just bullshit. So anyway, the first 6 minutes of the video, he's just doing this big preliminary kind of explanation of waves and how photons are waves and explaining how they're waves. It's crap. And in that description, there was the one part. The math gets sort of interesting just because he uses the word wavelength and then frequency, and then has a formula that looks like it's a formula. It says something. Where you multiply the wavelength times the frequency and get the speed of light. Well, yeah, because wavelength is an inverse number to frequency, right? So as you go higher on the spectrum, more energetic, frequency number goes up, but the wavelength number goes down. So it's inverted. The two are inverted, which doesn't make much sense, right? I mean, they're essentially reciprocals of each other. So of course, if you multiply them times each other, you'll end up with the constant that they're both based on. So it's not even really math. And I think there's a lot of that in physics, where they just keep doing this theta crap and sine theta crap or cosine theta crap. Instead of just saying, look, we're going to divide it by the incident number, or something like that. I mean, it's so blatantly non-explanatory, and it has these little tricks in it. The math is just tricks of math. And again, when you're working with numbers like frequency and wavelength, which are basically descriptions of the same things, just inverse numbers, one going down scale while the other one goes up scale, describing the same thing, I think it's okay to say, hey, this is a little bit of bullshit, isn't it? Why don't you just use the period and forget about this crap? So anyway, so that's just a minor complaint. But there's a lot of errors in this video. I mean, just one little one later on, he's talking about reflection, and he starts talking about, this is a minor error, but this is the kind of thing like doctors of physics shouldn't be making these kind of mistakes. Where he's talking about the screen being blue because the light reflects off of it and it absorbs the red light. That's not why the screen's blue. The screen's blue because it's projecting light. It's not reflecting light. I mean, that's sort of important. Anyway. Alright, so this is the two-slit experiment. So I just play the video and I'll just, lament how this is what's so fucking wrong with conversation on the subject of quantum mechanics.
Well, with electromagnetic radiation, you can't. So it'd be nice to be able to demonstrate the wave property in an experiment. Well, with ocean waves, water waves, it's well known when those waves hit obstacles how they behave. So it'd be neat to arrange an experiment where an electromagnetic wave hit some obstacles and displayed those same kind of wave characteristics. So that's what we're going to do. So consider this. We're going to take a slit, a tiny little hole poked in the screen, and shine light through it, and then look far away at a wall or some other screen where that light hit.
I mean, I wonder what age group this video was meant for. Like 7-year-olds? Neato, Doc. Can't wait.
And see what that looks like. So I think you understand this. This is like poking a hole in a pie plate and shining a flashlight through it onto a wall. you know what you would see. You'd see an image of the hole that you poked, and it'd be diffuse around the edges, and it'd be bright in the center. That's because the light is diffracting and spreading out around the edges of the hole you've poked. That's exactly what I've drawn here. I have a light passing through a hole, hitting a screen far away, and I've plotted the intensity distribution. Now this is monochromatic light, so only one wavelength involved. It's not like a flash.
There you go. So it's bad enough that, okay, you can get away with this, blob if you were using white light, but it's certainly a fact that if you're using monochromatic light, you can't avoid diffraction. I mean, unless the hole is as big as a basketball. I mean, this is just such crap. This is not what you get. Know what you get? This is what you get. Now, I don't know how you can't get more of like obvious diffraction pattern, right? This is a single slit. Nothing's been done to it. There's no manipulation in any way. Single slit, and this is the diffraction. Clear as a bell, as they say. I mean, I can move the image to different intensities based on how narrow the slit is. So here's the slit a little wider. I mean, not really missable. Not anything. There's no blob here at all. There's no, whoa, just one thing in the middle and a little bit of fringe. No, nothing like that at all. Clear, hard diffraction. Now, and this is supposed to be representing a sine wave, right? It's not a sine wave at all. I mean, these dimensions aren't, this dimension is not anywhere close to this dimension, but these dimensions are very similar in terms of their percentage. So it's clearly the central maxima is essentially two of these. Seems obvious to me anyway. Anyway. I just have a problem with this idea of this proportion doesn't seem proportional, in the sense that the gaps seem narrower, the dead spots than the bright spots, to be a sine wave. But it doesn't matter. This isn't the subject. So anyway, this is how he represents single slit diffraction. This is it. Nothing. No concession to reality at all.
Light. So it's more like a laser going through a slit. So what you have, though, is the same thing, a bright spot getting dim at the edges that I've plotted out here. So this intensity distribution is just like a probability distribution if it were particles. That is, let's say I shot bullets or BBs or something through a hole. Some of them would tick off the sides here and they'd spread out and they'd end out at the fringes, but a lot of them would go right through and hit directly across from the hole. So you'd have a high probability of a particle.
Yeah, but see, that's not even true either, right? Because if they were bullets and your hole was small enough, the probability of the light being influenced by the surfaces would increase as you narrowed the slit, quite obviously. And the same thing happens with light.
Hitting directly across from the hole, and slightly lower probability as you move away from the hole. So let's look at another slit. We could do the same thing with light, a second slit, and have the same kind of experience where a lot of particles or a lot of waves or a lot of beams hit directly across from the slit. So two slits together is where it gets interesting. When waves interact, that's how we can tell.
So it wasn't interesting when this is happening. It's interesting when this happens. Oh, I see.
They're waves. And you probably know this by looking at waves in the bathtub or waves on the beach. If there's something in the middle and waves hit them, there's a pattern that's predictable as those waves move away from the obstacle.
And it's also quite obvious that the waves go right around the obstacle, and as if the obstacle didn't even exist. And light certainly doesn't do that.
So this is like an obstacle to light waves, and we'll talk about light in the visible spectrum so you can actually see it. So two slits The light passes through them. What you might expect first is, well, you'd get a bright spot across from one slit and a bright spot across from the other slit. And it turns out for some wavelength and for some orientation of the slits, that's what you get. But if you arrange the slits appropriately, you get a very distinct pattern. Instead of two strong intensities across from slit A and slit B, what you actually see is a pattern of intensities, light and dark spots that are...
Okay, so we got enough of this, right? So this is it, right? So it's just completely ignore that this diffraction exists with single slits, that the two single slits were creating a diffraction pattern of their own. So just completely ignore this and pretend that it only happens when there's two slits. And why are they doing this? Because they want to argue the photon went through two things and created two separate waves that interfered with themselves. And that's not what's happening. So I don't know if I need to say anymore. Yeah, I really want to just get back to the basic theme here, which is this idea of this single force, gravity. And just understanding that this whole argument about what photons are, this whole explanation of his as this wave thing, carrying magnetic and electrical components in some who knows what form, is just so wrong. What a photon is events. And it requires more than one of these events. And the reason why it requires more than one of these events, let me argue again, that all photons are is gravity with a time cycle. So it's gravity with a period, with a reoccurring frequency. I hate to use that word. I hate to in this context. And so that's all photons are, is this separation between them. And this is the thing that's being recognized by the electron. And why is it being recognized by the electron? Because the electron, like every other thing that we call anything material or nuclear, is a thing in and of itself. And what electrons do, electrons are orbiting neutrons and protons, right? A pair. And they're creating a plus and a minus charge that's basically attracting and repelling. First it attracts, then it repels, and that's what's keeping the electron going around this. So it's hitting it with gravitons, these photons, the same photons, except they're not recognized as photons because they don't have a period. But there's still a directional influence. And so this nucleus of the atom pushes it on the electron and then pulls on the electron in the sense that it creates an imbalance in the pressure hitting this thing. So these little external arrows, the pressure from what's this side is being changed, alternated, based on which one of these is in what position. Which one's the first one, which one's the second one, what order they're in. Will decide whether this gets blocked from directional information or whether it receives directional information. So there's only a pushing force, but the absence of a push is the same as a pull because of the force that exists, the constant pressure. So an absence of pressure is the same thing as a reverse of pressure. I think you understand what I'm saying. Well, let's hope so. Well, anyway, so this is the picture of an atom. But the electron itself is its own little machine. So an electron has photons orbiting it. So what you can understand about a period is that when photons come in the right order, what's really happening is the photon comes in, it gets blocked from pressure. That means it gets more pressure this way, 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 always getting blocked by this thing. And ideally, if a second thing shows up, that will also create a gravitational connection. So it's like having the Earth on the opposite side of the sun. if the sun was a smaller gravitational influence. And so the benefit is that it adds this ability to have those gravities tying us together. We could be gravitationally connected to the Earth that's on the other side of the sun, and then the sun could be a weaker gravitational force because of the Earth we would be connected to. Obviously our orbit couldn't be as wide as it is. We'd have to have a narrower orbit, or we'd have to move a lot slower. But anyway, it doesn't matter. I don't want to get into all these complex dynamics. But what the period of the light represents is the orbital radius of the electron can carry. So it's essentially a description of what it takes, times pi kind of thing. 1/2 pi, r pi, or whatever the fucking thing would be to describe the diameters, which you're really talking about is the gravitational distance. But again, we have to recognize that these gravitational influences are moving at the speed of light. So technically, you couldn't have two things. I've sort of tried to explain this before. If two things are going to be connected to each other gravitationally on the nanoscale, on the smallest scale, the nuclear scale, that's where all the forces are. So again, the argument is all the forces are on this scale. And on our scale, they look completely different, but it's exactly the same force. The gravity that's affecting you is affecting your atomic parts. It's not affecting your matter. I could break you into tiny individual atoms, and you'd have exactly the same gravity as individual atoms. Because they're the things that are being gravitationally influenced. The pieces inside the atom actually are the things being influenced. The electron, for example. Well, anyway, so the gravity could never be opposite. It would always have to be some less than opposite, just because of the speed it would take for the gravity to get across this diameter. And so that speed would mean the real gravity has to be where something will be, not where the gravity. You know what I'm saying? It has to be in a position where it will be at the right time for where the gravity that was. So it's like I wouldn't have, my gravity can't be felt, at my neighbor's house. It takes time for it to get there. And so the thing has to be there before, you know what I'm saying? It has to have a lag equal to the time delay in the gravity getting there. So it will never be across from me to feel my gravity. It has to be something less than that. But anyway, that's the period of this light. That's why certain electrons will absorb certain colors of light, certain frequencies of light that will be absorbent, is because depending on the energy levels of the electrons in the atom will affect what their period is and what their internal clock speed is, or however you want to do it, the orbit speed of the electron. And that's going to decide whether it's going to grab one of these photons that'll be incidentally falling into the right path of some gravity. Oh, it gets a little complicated. See, the tricky part is that things replace other things. So it's almost like the idea of the light you see isn't the light that left. You're seeing different, the actual quantons that hit your eye are different than the ones that left, because they just keep getting replaced by something going somewhere else. So they keep getting replaced. Each one of these directional changes is actually a change of the identity of the thing. But patterns will always be repeatable. Patterns you can't change. You can't annihilate a pattern. So it's like almost when Einstein said energy can't be created or destroyed. No, the pattern can't be, in a sense, destroyed by gravity. It can only be destroyed by this material orbiting that can destroy the pattern, because it ends up going circular. And now once it goes one full rotation, it can leave in any direction. It can leave with any kind of period. So it's electrons that can break pattern, but not gravity, not the native field that the photons are traveling through. That vibration is completely kinetic, and even though it gets pushed sideways, that sideways doesn't matter because the other thing is going the way it did, so it's replacing another piece. So essentially when a photon is grabbed, it's knocking something else out, it's taking its place, and because it has the right period, it accepts the extra bit, and that's what increases the energy level, is that it essentially traps a new half a photon by the first photon knocking one out of its position. Now it's getting complicated. But anyway, this is what makes the universe run. This is it. This is the only force there is. It's just knocking stuff out of orbits of electrons. This is what the universe runs on. Yes, the atomic connections between protons, neutrons, and electrons are important, and all that kind of stuff. But the electron is the thing doing the collecting and distributing of energy. The collecting and releasing. Electrons are the battery. And they're the place where information can be destroyed, where pattern can be changed. Yeah, that's probably a good way to say it. Or even created. They're where pattern is created. Electrons produce photons. Gravitons exist everywhere. Zillions, gazillions, bazillions of them. Like a million times more, a billion times, a trillion times more gravitons are flying around you right now than photons. And it's only a tiny percentage of this whole field of energy that is in patterns. And the patterns are created by electrons. And it's created by the fact that these gravitons can, by association, by being forced into association with each other, will end up trapping each other in spirals. How else do I want to explain that? So energy isn't really what we perceive as energy. It's just the field of energy, the field of all the stuff that's the same, and it's just giving something that's the same a pattern. And it's the pattern, and the fact that the pattern can affect the electron in the sense that the electron can gain, add more, and lose some. The fact that it can store and release, that's what makes what becomes matter. Becomes creative. That's the right. I mean, creative is just such a non-deterministic word. But it's where pattern can condense. Yeah. It's all condensation in a sense. And that's what atoms do. They condensate energy. Alright. So I don't know if that was terribly helpful, but it's just a scale thing. That's all this is about. We're like I said, we're so distant from the real force that we just see it as insignificant. Okay, a photon travels across the universe. Well, that doesn't mean anything, but it all means something, and it especially means something incredibly important when you're on that level of a photon. When you're as big as a photon hitting you is a big event. And so on the scale of the real universe, the action, the amount of action is incredible. I mean, you can't even describe the fact that some little sound, I can snap my fingers, and the amount of energy in full photons moving through things is incredible. It goes, the sound, some of these photons that I'm moving right now, they're 100 miles from here. They'll change the balance of something. Something will hit, one of the arrows that I'm flying off of this when I'm doing this, that vibration, that arrow, will go 100 miles, go a billion miles. It's just that obviously it's at the source it's very condensed, and at a billion miles away, yeah, it's only one little photon. It's only one little tiny arrow. It's like the sunlight coming from the stars. It's just one tiny little speck of a very intense storm happening, billions of light years away. But it's just the fact of this density, the sheer density difference between our perspective. How like I said, this is a huge event in terms of the individual events involved in this happening. It's a huge earthquake kind of thing on that macro, that tiny scale. Anyway, and that's what people just don't, that's what fools us. Is we think this is this blob that we are is a thing. And in a sense, it's all just tied together with these little tiny things. The little tiny things are tying it all together. And they're tying it all together with these force laws about how many arrows you can push in one direction without breaking it. And how you can influence it, like shoving a magnetic field, a magnetic resonance. I've been watching some videos on that. And how you're changing the shape of all the atoms. Just changing the orbits by creating more arrows, in one direction. But that's the level it all happens on. All the forces are nuclear forces. Everything's communicated through these quanta. And the ones that are the obvious carriers are the ones that have a period, that have a frequency, a pattern. It's all pattern recognition, in a sense. If it can't be absorbed by matter, then it's irrelevant to the matter. It can't carry information, it can't do anything because it can't be meaningful unless it's part of some imbalance in the overall system. Anyway, I'll get too confusing. So anyway, till next time and such. I don't know if there's anything I really wanted to add. I just want to point out that when I talk about these orbits and I talk about the gravity, it's key to remember what I'm saying with the atom isn't held together with the same kind of gravity that's holding the solar system together, because it's polarized. So it has to do with this element of charge, and charge has to do with the polarization. It has to do with whether the gravity is more or less impactful. And that's kind of how a magnetic resonance works, is that you're basically polarizing the atoms, and now you're making them more receptive to the photons that you're transmitting and receiving. And that's what holds an electron to an atom, is that it's not being just pushed in, it's being forced out. So the pressure is being rotated on and off, backward and forward. So it's being pushed in. I hate to say there's no pull, but it's either blocking all of the gravity or none of the gravity And so in that sense, it's on or off. And off means not just the absence, but it means the pressure now will push you in. So that's why electrons don't crash into the nucleus of the atom, is because the neutron won't let that happen. Yeah. Okay, so anyway, till next time. And such. Yeah. That's for the video. So, I mean, the point I really wanted to just make is that this is the traditional explanation of the two-slit experiment, and it's a complete fraud. A complete fraud. It's a complete fraud.